So we will continue solve the quadratic equation using the completing square. So this time we focus on talking about if the leading coefficient is not equal to 1. So look at this example here. So 2x squared minus 4x minus 7 equal to 0. Okay, so I'm gonna follow what I did before. So we leave away square term and x term on the left side, and constants remove it, right? So I'm gonna add 7 here. Then this becomes then 2x squared minus 4x equal to 7 here. But the problem is we have 2x squared. If it is 4x squared, it is possible to make completing square because of 4x squared means 2x squared. Or we can also have another method that, like other question, we just make the leading coefficient equal to 1. Then which way is more familiar and it looks easier? In my opinion, I rather make the leading coefficient equal to 1 instead. Okay? Therefore, I'm gonna divide by 2 everything here. Okay, if you do it, then this form becomes x squared minus 2x equal to 7 over 2 like this. Now, looks really familiar because we have discussed those problems from the last video. Okay, so then what do we add the constant value here? Yes, half of this term squared. So negative 2 over 2 becomes negative 1. So negative 1 squared means positive 1. So you combine 1 and 1 on the both sides. Okay, if you're factoring out, this becomes x minus 1 squared, that equal to 9 over 2 here. Okay, because 7 over 2 plus 2 over 2 becomes 9 over 2. Now next step, you take square root both sides, and don't forget plus and minus. Then this becomes x minus 1 equal to plus and minus. You can see 3 over root 2. Okay, now combine 1. Then x equal to 1 plus and minus 3 over root 2. But we usually don't write irrational value on the denominator. So just multiply root 2 both and numerator and denominator. Then x becomes 1 plus and minus 3 root 2 over 2. That will be the answer. And the reason I don't go any further, because this is a rational term and this is irrational term, so we cannot actually combine them. So that should be the final answer. So let's look at one more problem, which is 3x squared plus 24x equal to 7. So remember what we have done. So what did we do before? Yes, we divide by leading coefficient, which is 3 this time. So we divide by 3 every term here. Okay, then this becomes x squared plus 8x equal to 7 over 3. Now we combine half of a squared, which is 4 squared, 16, right? So 16 and plus 16 here. So if you factor this out, then it becomes x plus 4 squared, and you combine this fraction, then 7 over 3 plus 48 over 3. Therefore, x plus 4 squared equal to 56 over 3 here. Okay, then now I continue here. Then now we take square root both sides, don't forget plus and minus. Then this becomes x plus 4 equal to plus and minus square root 56 over 3. Now subtract 4 on the both sides. then x equal to negative 4 and plus and minus root 56 over 3. But like as I told you before, we don't want to write irrational on denominator, so that you can multiply root 3 both on numerator and denominator, then x equal to negative 4 plus and minus, so root 168 over 3. Okay, so let's figure out whether 168 we can simplify. So 168 means we can make 4 times 42 and then 7 times 6. As you see, root 4 is 2, therefore x equal to negative 4 plus and minus 2 root 42 over 3. That should be the final answer for this problem.